Alright, so today I'm going to be showing you how to create a gear system for your car controller. So this gear system is going to have a clutch, it's going to have neutral and as many gears as you like, and it's basically going to emulate a car engine. So as you can see here, you are going to start the engine. I'm gonna floor it. It's going to rev. It's going to reach the rev limit, and then it's going to change gear. And so now if I brake, as you can see, it's going to decrease the gear. And if I come to a complete stop, it's going to go to neutral. I can also press the clutch key, and now as you can see, if I rev the engine, it revs and doesn't have actual torque in the wheels. Also, here in the inspector, we can have as much power as we want. So here it's 100 horsepower, but we can put as much power as we want. And this is here is the horsepower curve. So the y-axis is the maximum horsepower, and the x-axis is the RPM. So that's basically what you would have seen if you put your car in a dyno. You can also change at what RPM you change gear, and what your maximum gear is, and idle gear, and also how we're gonna show you how to set up this gauge cluster right here. Alright, so first thing we're going to be doing is setting up our gauge cluster. So here we have these two images, which are sprites, and we're gonna go into our canvas. So we're gonna go here, we're gonna create a new image. So we're gonna go to UI, image, and we're gonna drag and drop our gauge cluster there. Perfect. So we set this to native size and we scale it down a bit. Yeah. Alright, let's put this here. Perfect. We also need to use our needle, so I'm gonna copy paste this and I'm gonna put the needle here. So yeah, obviously this does not, it's not the correct size, so we're gonna scale it back down. I think that's good enough. Yeah, perfect. Okay, so now we're gonna put this as the parent. We're gonna rename this to gauge cluster, and we're gonna create the text for the RPM and the gear. So the text MES Pro, we're gonna set this to RPM 6000, I guess. We're gonna set this to auto size. Let's make the minimum a bit lower. We're gonna downscale it. We're gonna put this here. Maybe without the RPM, I think it will be better. Or, well, whatever. Same thing. Okay. Perfect. We do the same thing for the gear. So 0. Alright, that's good. And so here, in our needle, when we rotate it, we're gonna see that it doesn't rotate where we want it to rotate. So to fix this, we're gonna create a new empty panel that's gonna scale up to here. We're gonna delete the image component, and we're gonna put the image cluster, the image of the needle here. So we're gonna set this to needle, and when we rotate this, as you can see, it rotates normally. But as you can see in the 0 rotation here, it's on the 1000 RPM and not at 0, which is wrong. So we're just gonna rotate it a bit. I think it's gonna be 30. Yeah, that's 30. Perfect. Okay, so now that we have our basic UI, we're gonna go to our car, and we're gonna go to our car controller. We're gonna open it. And we're gonna go to our variables, and we're gonna create a few new variables. So we're gonna go here. We're gonna create a new float that's gonna represent our RPM, so our rotations per minute of the engine. A new float that's going to represent our red line, so at what point our engine stops giving power. And also for later, we're gonna have a float that's gonna tell us at what RPM our engine is going to idle. Perfect. So now we're gonna also create a variable for our text, so text mespro.text. But as you can see, this is right here. So this is because we want to use the text mespro class. So we're gonna go on top and we're gonna call this. So using text mespro. And as you can see here, the text is green now. So we're gonna call this our RPM text. We're also gonna have our gear text. Perfect. And now we also want to have our needle, and so that we can rotate it from 0 to 6000 RPM, for example. So we're gonna have a public transform RPM needle. Perfect. Okay, so now we go to our update here, and we're gonna change our RPM, sorry, not our RPM, our RPM needle to rotate based on the RPM, and yeah, also our RPM text and our gear text. So our RPM text is going to be RPM, or actually we don't want the RPM, we're just gonna have the number, so RPM, perfect. And also, actually we can have the RPM. And our gear text is going to be our current gear, but we don't have a variable for our current gear, so let's create a new variable for our current gear, public int current gear. And since we're gonna use this later to access an array, we're gonna add 1 to this. So current gear plus 1 is going to be our gear dot toString. Perfect. So now we also want to rotate our needle. So to do that, what we want to do is rotate our needle transform. So we access the needle transform, RPM needle dot rotation is equal to a quaternion dot Euler angles, or sorry, Euler only. And so this is going to be 0, 0, so we don't want it to rotate like this or like this. We want it to rotate like this only. And now our rotation, which is going to be basically how far our RPM is based on the circle. So if we say that 0 is at 30 degrees and our 6000, so our red line is at, for example, 150 degrees, we're gonna calculate the distance based on that. So we want to know where our 0 and max RPM is, so we're gonna create a new variable here, which we're gonna call public float minimum needle rotation, which is going to be in our case something around 30, and our public float maximum needle rotation, which is going to be around 150, I think, 200, something like that. Okay, so we go back here, and we go to our quaternion, and now we interpolate based on that. So we use the mathf function .lerp, and we're gonna lerp between the minimum needle and the maximum needle, and the time will be the RPM divided by the red line RPM. Perfect. So let's see if this works. All right. So right now we set up our RPM, or our max RPM and our idle and our red line, etc. So here in our needle, we see that Z is 30. So our 0 is 30. And if we rotate it, so that, as you can see, it rotates, and let me rotate like that. So if we put this at around 6000 RPM, which is going to be our red line, like 6500, I guess. So that's minus 220. Perfect. So we go back to our car. And here, where we have our minimum needle rotation, we're gonna set it to 30, which is our 0. And the maximum to our minus 220. Perfect. Our current gear is 0, which is good. Our RPM text is going to be our RPM. I think that's this thing here. Our gear is this one. And our RPM needle is this object right here. Our red line is going to be at 6500 RPM. And our idle RPM is going to be at around 800. Perfect. So let's test this. So as you can see, this is at 0 right now. But if we increase the RPM with the editor, we can see that, sorry, this is super slow. So if we set this to 800, you can see that this here moves. So if we set this to 3000, this is going to be at around middle, at 6000. This is almost RPM. So yeah, perfect, that works. So now what we want to do is to actually have a rotating engine. So before we get started, I'm going to explain to you how we use horsepower curves and torque curves to calculate how much torque is applied to a wheel, and what the correlation between the horsepower, the torque, and the wheel power is. So yeah, to do that, I'm gonna show you real quickly the curves. So usually when we see a horsepower curve on a dyno in a car, we have something like this, which is This is power. In our case, horsepower. And here we have the RPM, which starts from 0 and goes to around 6,000. And the horsepower, let's say 200 here. So we usually see something like this. We start at 0 and we go like this. We peak at around somewhere around here, it's like 700. And then we start falling off since we hit the rev limiter. And that's the power curve. This is the power curve. Perfect. So this translates to a torque curve based on the wheels. So here we have our torque in Newton meters. We still have the RPM as the x-axis. So this is 0 to 6,000. And what we see in the RPM is that the actual torque of the engine, based on this thing here, so if you actually do the calculations, we're gonna have a torque curve that's going to be like this, yeah. So what is the correlation between these two? The calculation basically is, so the torque is equal to our horsepower with the variable of the RPM. So if we're here, this is going to be 100 RPM, 100 horsepower. So this divided by our RPM. So this is the main torque of the engine. And then we have other factors such as the gearing and the differential. So we have our current gear. So we actually multiply this by our current gear and our differential ratio. Perfect. And so this here is in I think it's pounds per square foot, something like that. But to convert it to Newton meters that Unity use it, we multiply that by the standard. What's this called? Anyway, we multiply it by 5,252, and also by how much our clutch engages. So if our clutch is not engaged, the engine spins basically as much as it wants without any force being attached to it. But if our clutch is fully engaged, then the wheels spin exactly at the speed of the engine. So we also multiply our clutch. And that's basically how the horsepower, what's the correlation between the horsepower and the torque curves. Okay, so let's try this out in Unity. So we go back to Unity and we go back to our script. And if the OS opens, yeah, perfectly. Okay, so let's start by creating our new variables. So we're gonna start by creating a new array, which is going to be our gear ratios. So a public float array, which we're gonna call gear ratios. Also, we're gonna have a new variable, which is going to be our differential ratio. We also want a new variable for our current torque, to know how much torque we have in the wheels, and also we want a variable for our clutch, to know if the clutch engaged or not. Perfect. Okay, so now we want to actually engage the clutch, so we go to our input, and so we go around here, and we set the clutch to be equal to, basically, if we are pressing the clutch key, it's going to be 0, and if we're not pressing the clutch key, so it's going to interpolate from our current clutch value, so from 0 to 1, based on the time that has taken. So let's see, it goes smoothly, it doesn't basically jump from 0 to 1 immediately, which is going to break the traction of our wheels. So we're gonna set this to input.getKey. Our key is going to be the shift, so key.left shift. So if this is true, then our clutch is going to be disengaged, so 0. Else, it's going to interpolate between our current value, so clutch, to 1 and times the delta time. Perfect. And so now we want to create a new function to actually calculate our current torque. So we're gonna go to where we calculate our motor power. So this is apply motor, which is around here, yep. And so, yeah, we delete all this, almost delete it. And we keep. And we keep these two things right here. Yep, perfect. So instead of motor power, we're gonna have our current torque. Perfect. And now we set our current torque to be equal to a function we're gonna create in a little bit, which we're gonna call calculate torque. Perfect. So this calculate torque, we're gonna put this here. It's going to return a float. So float calculate torque. Perfect. And so we set our temporary value of torque to 0, to be equal to 0. And so we say if the engine is running, is bigger than 0, then if our clutch is engaged, so that means that if our clutch is not engaged, which means that our clutch is less than 0.1 F, then our RPM is going to be interpolating between what's bigger. So it's going to be either our idle RPM, or we're gonna calculate how much gas the player's pressing. So, for example, if you have the clutch down and you press the gas, the RPMs are going to rise, which is the normal thing. But if you let off the gas, the engine is not going to stall by going to 0. So that's the idle RPM. So mathf.interpolation again between our RPM and our mathf.max, so which is higher, either the idle RPM or the maximum RPM times the gas. So this is going to be our idle RPM, and this is going to be our red line RPM times our gas input. Perfect. Plus random.range plus a bit of randomness, so that it actually goes up and down when we reach the maximum RPM. So 50 and minus 50, so minus 50.50, and we're gonna type, it's going to take around the delta time. Perfect. So if the clutch engaged, now we actually calculate our actual RPM and the wheel RPM and our actual torque. So we're gonna create a new variable, which we're gonna call wheel RPM. So private float wheel RPM. And, this should be another case, and we go here, and so wheel RPM is equal to the absolute value of, take the average of the two wheels. So that's going to be the RPM, so the colliders dot rear right wheel dot RPM plus the rear left wheel dot RPM, and all this we divide by 2, and we multiply this by our gear ratio dot current gear times our differential ratio, and this is going to be our actual wheel RPM. So now we calculate our actual engine RPM from that, which is going to be the interpolation again, so that we have a smooth and linear RPM needle. So the RPM is going to be our RPM, and once again we're gonna have the mathf dot maximum. So our engine is going to be going up until the idle RPM and a bit lower, and we can't allow it to go even lower since it's going to stall, and we don't want that. So it's going to be equal to our idle RPM minus 100, or our wheel RPM, so either which is bigger, and we're gonna interpolate that by time dot delta time times 3f. Okay, and so our torque now is going to be equal to our horsepower times our RPM. But right now we don't have a horsepower curve, so we want to create a new curve for our horsepower. So we're gonna go here and we're gonna say public animation curve. So that's the way we get the animations dot horsepower to RPM curve. Perfect. So we go back to here and we set our torque to be equal to our horsepower to RPM dot, and we evaluate this. So it's the evaluations between our RPM and our red line RPM times our motor power. And if we go back and look at our torque function, we need to divide this by the RPM and our current gear, and we multiply this by our current gear and our differential ratio, the 525.2, and the clutch. So we divide this by our RPM, And we multiply this by our gear ratios, that's 0, sorry, current gear, and time differential, times 5 to 5 floating points, and then the clutch. Oof, that's a big one. Yeah, sorry about hiding this. And then we return the torque. Perfect. Okay, so let's see if this works. We go to our Unity. We go to our car controller. We set our gear ratios to be equal to a normal gear ratio. So I think this starts from 3, 2.5, 2, 1.5, 1, and 0.8. Yeah, it seems like a normal ratio. So the differential ratio is usually 2 to 3 based on how of what differential you have, and our curve is going to be like this. So this is a normal horsepower curve, as you can see. It looks like this. And we're gonna actually, the only thing we want to change here is to actually set this to 0 when we surpass our RPM. And also we can make it a bit more picky, so it's a bit more fun for a racing game. And so we're gonna make it like this, or actually we're gonna change this here to be a bit more picky. Yeah, like that. Perfect. And let's see if this works. I hope this works. Let's see what our motor power is. Let's put this to 100 so it's more normal. Let me close the audio so it doesn't bleed our ears. And let's see. Perfect. So, as you can see, the car is moving. That's good. First thing first. We're actually having our RPM and actually going forward. And as you can see, it's going to limit itself at the red line RPM. Obviously, this is going super fast, which we do not want it. So we're gonna increase the ratio to 4, I think. Maybe this works better. And let's see now. Okay, yeah, that's more normal. Okay, and as you can see here, it stops giving power at around 6700 RPM. Perfect. The only thing I've noticed here is that the RPM is having a floating number, which we do not want it. So we go back to our UI, and instead of RPM, we're gonna set the RPM to string. I think. Let me actually check what I have done here. Yeah, to string, and we're gonna have this as 0 and 0. Perfect. I think this should work. Let's see once again. Perfect. The RPM is perfect here, so it stops at 607. Perfect. Okay. Okay, so what we want to be doing now, we can change the main camera to be a bit faster so it can follow up with our car. So the speed should be around 5, I think. Let's see this. Perfect, okay, that's a bit more normal. Yeah, okay, that's more normal. All right, so now we want to create our actual gear system. So what we want to be doing is having a function that checks that if we're above a certain RPM or if we're below it, we either lower the gear or we increase the gear based on that. Okay, so to do that, we're gonna create a new state machine to check what we discussed earlier. So, create this. We're gonna create a numerator. So we're gonna call this public enumerator gear. Okay, set this to gear state, and we're gonna have the neutral state, the running state, sorry, this should be uppercase, and our checking change. So if we're checking, we're checking basically if we're changing gears, and if we're actually changing gears. Okay, perfect. So here, actually this should be outside our class, like this, and we're gonna set this as a private gear state. Gear state. Perfect. All right. Okay, so first things first, we want to create a new function to check our state, and actually not even a function, it's going to be an enumerator. We're gonna call this change gear, and it's going to take one variable, which is going to be our gear change. And first thing we do is set our gear state to be equal to checking gear, so checking change. And now we do our logic. So if our current gear plus our gear change is bigger or equal to 0, we do our logic. So if our gear change is positive, then we increase the gear, so increase the gear, and if it's negative, decrease the gear. Perfect. So to increase the gear, what we do, basically, we're gonna have two steps. First of all, we're gonna wait a few seconds to check that we're actually wanting to change the gear and we're not spinning the wheels or anything. So we're gonna wait yield return new wait for seconds, and that's going to be around 0.7 seconds. And so now, if our RPM is still bigger, if it's not bigger than our if our RPM is not bigger than our crazy gear RPM, so yeah, we need to have a variable here, which is going to tell our script at what RPM we should change gear. So we're gonna go once again to here, and we're gonna create a float, increase gear RPM and decrease gear RPM. And we're gonna go back. Sorry, I have an error here. Yeah, okay. So if it's lower than our actual RPM, so if we have managed to know that we should not increase the gear RPM, or the current gear is bigger than our gear ratio, so current gear is bigger or equal to the gear ratio's dot length -1. Then we stop checking and we check again a bit later. So the gear state is going to be once again back to normal, so gear state dot running, and we're gonna break the enumerator. Same things for the gear change. So if the gear change is negative, so we're decreasing gear, we check if our RPM is actually we need to actually wait a few seconds, so yield return new wait for seconds, which is going to be a bit lower, since when we're decreasing gear, it's quite obvious we want to decrease the gear and we do not want to wait. So the yield return new wait for seconds is going to be 0.1, and we're gonna check now that the RPM is actually bigger than our decrease RPM, or that our current gear is actually smaller to or equal to 0. In either case, we want the current gear to be equal to 0, and our gear state, and we want our gear state to be equal to our gear dot running, and we break once again. So if this does not happen, so that means that we actually want to increase our RPM, we set our gear state to changing, and we wait now a few seconds. Although these few seconds, we're gonna actually set this up at our variables. So here a public float change gear time. We're gonna set this to about 0.5 seconds, and yeah, change gear time. Perfect. After that, wait, we actually change our gear, so current gear plus equal the gear change. And after all this, we set our gear state to be equal to running. Sorry. What? Am I outside the enumerator? Yeah, I'm outside the enumerator. So gear state equals gear state dot running. Perfect. Let me check that this is okay. Okay. So this should be here, if I'm not mistaken. Yeah, perfect. So what we now want to do is actually instantiate our change gear. So we go to our actual get torque. So where is the get torque function? Yeah, calculate torque. And we say if our gear state is equal to running, and our clutch is not pressed in, is engaged, then if the RPM is bigger than our increased RPM, then we're gonna start the coroutine of change gear with 1 as our variable, and we're gonna do the same thing for if it's lower than our decreased RPM. With the only difference that this is going to be a negative number. Perfect. What we also want to do is change our clutch so that it does not engage when we want to change gear. So we go to our clutch, which is where it's here, and we say if the gear state is not equal to gear state dot changing, which means that we're not changing gear, then we're gonna set our clutch, and else if it's actually changing gear, we're gonna set our clutch to 0. So before we test anything, we want to make sure that when we start the engine, our gear state is equal to gear state.running. Okay, and also we can go back to our engine audio, and we can actually make this a bit simpler, since we can just have this here and, as our actual RPM sound, and not this whole thing here. So same thing for running sound. And let's test our script now. So to get our car engine audio to work, we want to go back to where we actually return our gear ratio. So instead of speed clamped, we want to have our RPM, and instead of max speed, we're gonna have our red line RPM. Perfect. Also, before we end and we check if this works, we're gonna go back to where we change our needle here, and we're gonna actually set this to red line times 1.1 so that it doesn't max out and just stops working. So let's see how that goes. So here in our car, we go back to our increased gear RPM, and we set this to 5500, and our decreased gear RPM to 3300. Okay, let's see how this works. So here, our car engine starts, we press the gas pedal, it revs, and now as you can see it changed gears as well. Let me brake a little bit, and as you can see when we brake it tries to... As you can see now the wheels are sleeping, it's actually having the correct RPM, and when we brake it decrease the gear gradually, which is how a normal car should work, and this is almost perfect. Now the only thing missing is the neutral gear, so let's make this happen as well. Alright, so to actually get the neutral running, it's pretty simple. We go back to our car controller, and first thing first, we want to bypass the gear state running, so we make sure this the gear state is not equal to neutral. And then, after that, what we want to do is go to the calculate torque, and here we say that if the RPM is lower than the idle RPM plus 200, and we're not pressing any pedal, then also we want to check that our current gear is less than, and our current gear is equal to 1, I think? No, 0, yeah. And our current gear is equal to 0, and our gas input is equal to 0. Then our gear state should be equal to neutral. Okay. Also, what we want to do is go to our clutch and to make sure that we disengage the clutch if it's at 0. So here we say that if the gear state is not equal to... Actually, let me look at my notes. Yeah, okay, if the gear state is not equal to changing, and our gear state is equal to neutral, then our clutch is going to be 0, and if we press the gas pedal, is bigger than 0, then our gear state is going to go from neutral to running. So gear state going to be running. Perfect. And actually I need this here. I don't know why I set the gear state changing 2 times, and we put this at an else statement, like that. Also, we can go to our RPM, our gear text, and we can say that if our gear state is equal to neutral, then we're gonna have an N, and if it's not, we're gonna have our normal string. So let's see if this works. Okay, so let's see if this works now again. We go to play, and our engine is not running. We press the key to start it, and it's still in neutral, which is good. Now we press the gas pedal, it goes forward, it changes gears, and so if I'm gonna abruptly stop now, it's going to decrease the gear, and then it's going to go to the neutral. Perfect. And then if I press the gas pedal again, it's going to go from neutral, and it's going to, once again, increase the gear. Here I need better gear system, sorry, not gear system, better traction. And so increase the gear once again. I need to go back to track, which I'm not doing, but whatever. You get the point. The gear system works. And so now we have gears, like a normal car, and if we want, we can increase either the motor power, which basically our horsepower, or change our horsepower curve here to match a more realistic car. So yeah, that's pretty much the whole video. Thanks for watching. I appreciate if you leave any comments and suggestions for future video you'd like me to do, and take care.